Example 2, we get some practice with multiplying and dividing. We've been given two different functions now. X squared, f of x equals x squared minus 1, g of x equals x plus 1. And in the first problem, we have to multiply the functions. So again, this f times g of x can be rewritten as f of x times g of x. It's a multiply. And again, like we did on the last slide, we're going to substitute for f of x what it equals, and we're going to substitute for g of x what it equals. So this is x squared minus 1 times x plus 1. Now here's a case where we should FOIL this to simplify. We wouldn't leave it in that form. That will be x to the third plus x squared minus x minus 1. And there's no combining of like terms. It's in standard form because the highest power term is on the left, descending order of powers. So that's as simple as it gets. Okay, out of the four operations, the one that will cause us the most trouble is going to be the last one, the divide. And it's going to give us more trouble because of something that you already are familiar with a little bit, which is the domain of a function. You're used to thinking of the domain of the function as x values. But it's more than just saying, here's a set of ordered pairs, let me show you all the x values. In functions like this, you'll see how domain comes into play. First of all, because it's f over g of x, then I'm going to rewrite it as f of x divided by g of x. And just like we've done in the previous three, now we're going to substitute for f of x and g of x. That's x squared minus 1 divided by x plus 1. And this is really the place where you have to consider the domain of this new function, this f over g of x. And what you have to keep in mind is you cannot divide by 0. And so we have a potential problem here because we are dividing by an expression, right, that includes a variable. And if we choose that variable to be the wrong number, we would actually be dividing by 0. What number would we substitute in for x to make the denominator equal 0? It's kind of like when in chapter 6 when we did polynomials, right? The 0 in this case is -1. So we can answer the last part of this question, what is the domain, by saying that x does not equal -1. Right? We cannot let x equal -1. It can equal any other real number. So it's really, the domain is all real numbers except x does not equal -1. And most of the time you would write it just like this. Just say x does not equal -1. Now we're not done because we didn't simplify this. And we should recognize by this point, x squared minus 1 is a difference of squares, and it factors as x plus 1 times x minus 1. And now we notice we have a common factor in the numerator and denominator, so we cancel them. And this equals x minus 1. So we should simplify if we can. A lot of times at this step, you can't simplify, so you don't. But if you can, you have to. And in this case, x squared minus 1 should have been recognized pretty easily as something we could factor. And look what happened. We were able to factor out the denominator. Now, that does not change the domain. Just because over here we don't see a denominator, so we're not dividing by 0, when we set this function up, we definitely had a denominator and we had a value of x, which we had to restrict from the domain. So we have to consider the domain, not here, but here. So the domain is right there.